My name is Miranda Cao, and this is experiment 1 for Physics 2212. The purpose of this experiment is to use U-tapes as a model for electron movement and interaction and calculate the amount of excess charge on one piece of charged U-tape. And the results I got for this experiment are that the U-tapes are positively charged and the charge is 1.167 times 10 to the negative 8 power coulomb. They are deficient of 7.292 times 10 to the 10th power electrons. The fundamentals of this experiment include Newton's second law and Coulomb's law. For Newton's second law, it states that a force is equal to the mass of the object multiplied by its acceleration, and the Coulomb's law states that the electrical force between two charged objects is directionally proportional to the product of the quantity of charge on the object and inversely proportional to the square of the separation distance between the two objects. For this experiment, the system is tape A and B, and the surrounding is everything else. The initial conditions are that electron charge on the tape was 0 at the start, and the tapes are equal in length. Some assumptions I made for this lab are that the point charge is located at the center of the tape, the air resistance is neglected, and the charges are equally dispersed for both tapes. I started off this lab by creating two U-tapes by taking two tapes together like figure 2 and pulling off the tape on the top of the base tape and repeated this step twice. And that's how I got U-tape A and U-tape B. And then I observed interactions between tape A and tape B, one U-tape, and various charged objects. And I also observed the motion of a suspended U-tape like figure 4. Some observation I made from this lab was that the tapes repel each other but were attracted to neutral objects like a book or a table, and they are also attracted to my hand and a negatively charged pen. So the conclusion I drew from my observations was that the U-tapes are positively charged. For this experiment, I measured the length and the width of tape A and the distance between tape A and tape B. From these measurements, I calculated the mass of tape A, the magnitude of gravitational force on the floating piece of tape, the magnitude of electric force on the floating tape, and the measured electric charge on the floating tape based on the fundamental theorem that I talked about on the second slide, and then I further calculated the number of electrons deficient on the tape. And then I used Python to derive a computational model for this scenario. When considering the tape as a single point charge, the magnitude of the charge was 1.773 times 10 to the negative 4th power. And when considering the model of a line of charges, the magnitude of charge was 1.962 times negative 3rd power. Like I said, some assumptions were made, such as ignoring the air resistance and assuming that the charges are well disturbed. And here is a screenshot of my code on this slide. If the charges were reversed, nothing would happen numerically in terms of this experiment because the opposite charges will still attract and the same charges will still repel. And to answer the why question, I said that because these two models are based on different assumptions about charge distribution, the values obtained are obviously going to differ. The point charge assumes that all the charges is concentrated at one single point, while the line charge model considers a distributed charge along the line. And in this case, the line charge model reflects a more accurate result because it is more suitable in this situation where the charge distribution is linear and extends over a limited length. The discrepancies between the result might be because of human errors in measuring the length and the width of the tape, or the loss of electrons on the tape due to human interactions with the tapes. In conclusion, the experimental result confirmed that there was a significant number of electrons transferred from the U-tape, resulting in a net positive charge. Thank you.